here for 2 sessions, today and then again next week. And our goal is for today to talk about sharing, just how you can set up the files in a way that you can either work on separate parts of the files and bring them all together as one big master file, okay, which is a very common way of working. And we'll also look at a second way of sharing where if you're set up on a file sharing network, like 2 or more you can be working on the same file at the same time, okay, which has some complexities and network hocus pocus we have to go through to get it to be set up properly.
Some advantages.
Yeah, it has some very strong advantages if you want to be able to work together in a very synchronous, everyone doing things at the same time, and really controlling things on an element by element basis is really being able to have that level of control. Because virtually introduced, underlying the building model is really a big database of information, and really we can control individual objects in that database just one at a time, and be able to make changes to individual pieces of it, and still keep it overall in coordination and our processes. So, in thinking about sharing, that's where we're going to be spending our time today. And then next time we're going to spend some time looking more specifically about how we go through and do some detailed modeling, structural systems, and mechanical systems, and some of the things that really go through the kind of system models that you're building. So we'll look at both those things. But in thinking about sharing today, we're really going to look at it 2 different ways. Let's kind of talk about what those are and then really like how they're typically used. Okay. The 2 different schemes for sharing really are based on the notion of really how teams tend to work together. Okay. Because really, the tools for creating building models, they all work fairly similarly in terms of what's going on, but really the important thing to understand is not really so much what the tool is doing as much as really what your overall workflow process and how you want to share the information is, how you actually want to coordinate that. And that's really one of the most important things for you guys to decide now is before you really get modeling very deeply in your buildings to understand how you're going to break up the problem. Because on any individual building model, if there are really 4 of you who are potentially working on pieces of it, you have a whole lot of different choices about how you may want to go through and do that. Okay, so as a team, you have to sort of decide really how you want to approach that. And the way it will often happen in industry is just because we tend to be organized by different disciplines, we're all trained in different disciplines and are licensed to do different kinds of work, very often things will be broken up that way. So you have a team of architects, maybe several architects, often many architects working on aspects of the building. You'll have another team of structural engineers working on the building, also adding information to it. MEP engineers adding information to it. Okay, and ultimately people like construction management folks who are consuming all that information and using it to plan the construction process through the scheduling and the estimating out of that model. So it's pretty common to go through and break things up based on discipline. Okay. And when we break things up based on discipline, the most common way of handling it tends to be for each discipline to have their own model and you're going to link those models together. And the reason we do that, it isn't so much a hardware limitation as much as it is just kind of an organizational constraint in that each different discipline wants to be responsible for their work. They really want a little bit of a firewall between what I'm doing and what the other disciplines are doing. So as an architect or a structural engineer, I don't necessarily want the architect to start to be able to move around my beams and columns and resize all those things for architectural convenience. So I like to keep my structural work together in its own model. The architects keep their work together, and the way we sort of interact with each other is we can share models with each other in a kind of you can look, but you can't really touch sort of fashion. In that I can see what's in your model, I can bring it in, see where your model and my model intersect with each other, where things overlap, where they're going to connect. But I can change things that are in my own primary model. I can't really change things in your model. And there's some advantages to that, in that if there really is something that I need to have changed, I pretty much have to call you and ask you to make the change, which sort of puts a little loop of accountability and responsibility to the whole thing. So that's kind of the first way of sharing models, is really this notion that we'll all work on independent models and then just link them all together, where you can work with anything in your own model and any of the linked models, and there can be more than one. You have a structural model that comes in, an interiors furniture model coming in, an MEP model coming in. It could really be any number of models that we bring into our courses. But those linked models, you can't really make changes. You just sort of inherit the changes. So if anyone makes a change on their end, the next time you load your model, you get the latest version of everything you have already together. Okay, that's actually a pretty common way of doing it. So we'll start by looking at that as a mechanism and how we go through and set up something like that. Then we'll move into the other way, which is actually sharing an individual model. But even within linking, let me kind of sort of give you some different ideas about how you might want to use that, and have you think about how you want to do it in terms of your team and how you're going to divide your work up. Because as we link models together, okay, one way of linking models is by discipline, so having the architects, which is the structural engineers, which is the MEP engineers, all working on different disciplines. Another way to do it, though, is if it's a fairly large building, you can actually break it into different zones and regions. So if there's a building that has several wings to it, and there's several of you working together, if there's really someone who's responsible for wing A and someone else who's responsible for wing B, it's okay to actually work on those as two separate models. This needs sort of a way of coordinating the work so that it all lines up kind of very nicely, like where the interfaces happen. So some people will divide up work that way. There'll be different regions of the building. I've seen people divide up buildings by floors. There's any number of ways you can do it. But one thing for you guys to think about, just sort of rather explicitly up front, is just really how you want to subdivide the tasks and kind of just really just break it up for yourself. Because there's really like, again, any number of schemes that can work, and it's really, there's nothing about the information model that's going to dictate to you what's best. It's really going to be more what you're comfortable with as a team for dividing your work and who has expertise in different areas and how you're going to get that work coordinated back together. So, like, of the teams here, have people talked about it at all yet? How you're going to work as a team of four? Like, what sort of schemes are you guys considering doing?
Who has started modeling? Which team?
Okay. Yeah. So, as a team, have you thought about yet how to like approach it as a team of four?
I thought we didn't really know what and we start. We can just one people can go on the line, and the other people can group us. That was
So that's not exactly collaboration, right?
Yeah.
So one person is doing in your model and the other is watching until the one person hands over to the next person. So that's not what we want you to do. Although the building is simple enough, you can do that. But in your presentation, you're going to show how you have collaborated. And the whole purpose is learning how to collaborate, because what Glenn described is how buildings are modeled and how buildings are designed and constructed. It's not one person modeling and another person watching and providing feedback. So what I want you to learn in this class is not so much the software, but how to put all these pieces together. So you're part of which team? Can you remind me? Three. So what other teams started? You guys, okay.
Okay, cool. Yeah, and you can do hybrids of that. So, there'll be two different architects, one working on floor one and one floor two.
That works. And actually, all the examples that you have given by section of the building, by floor of the building, by discipline of the building, other students tried, and I'm not really describing which way. So the one thing that you have to be careful in the previous teams had issues with like definition of where the floor starts or where the floor ends. A slab is part of the floor at the bottom or top, or like how do you share the columns or some of the elements, because they are not part of the third layer floor. As long as you have all of these procedures, I can really help and describe some of the things you should decide. As long as you have that, then there's no issue.
The first one, the concrete visualization
This is actually another really interesting issue. Last time we discussed things where, often the architect wants it, that really sort of belongs to the structural engineer. A lot of times what we end up doing is we include it in both models, and at the end, we one dominant. So
that's what you put up for the presentation. That's how you have to combine it. So, like, kind of thing, the relation that they will not take control of.
So if we're going to have elements in two different files, that happens. A lot of people want floor. Okay. But really, when we do go through and do the collision, we learn how to basically use different elements that unknown to be overlapping elements. And that's okay. Any model, any model for the building is being built. If we ran a strict collision test on, we find there's actually thousands of collisions that are still in it that are knowing collisions. Because, we just don't really take the time to model it down to the 16th of an inch everywhere that needs to be to really eliminate all those. We start learning how to find tests where the valid collision is versus something that is really more of a model that is blocking it. So you're on a very good issue. The issue about floor slabs in particular is one that's kind of a tough one because structural engineer really wants to kind of own it, but the architect will always put some sort of placeholder in there for the limited work on the building if there's no floor. And so that's okay. When we merge them together, we can turn on and off the usually on it.
That's a very good deal. That's where the expertise comes in. There was to Glenn remembers this when Tim started looking, finding places in the city. I remember many people saying that, oh, my job is going to be obsolete. Oh, the software is doing this classification. The software didn't do this meeting, and then I'm going to be out of job. But what the industry found out is this exact expertise. When you see those classes, you say this is a valid class, it has to be there, and this is a problematic class, it has to be resolved. And that comes with experience, right? And so I guess, I don't know if you remember those days.
Oh, very much.
Like, people started relaxing and like, this is a software that's going to help me, not going to take a...
It's interesting. What's really happened though is it's just shifted the work. It's really the grunt work is kind of a lot. It'll find a lot of things. We used to lay all these sheets of paper on a light table and take out markers and try to figure out where the overlaps were. Just like transmitting light through all these sheets and trying to see where things were flashing. And that was a horrid way of doing it. And it took an awful lot of time. We don't do that anymore, but now we spend our time really trying to teach the computer algorithms to be smart about identifying what good flashes and invalid flashes. It just shifts it around.
Mm-hmm.
There's no shortage of work. In fact, I think it's actually it's amplifying because we can do so much more.
But I remember this fear of automation taking away the job.
It always starts with fear. And then we figure out, oh my God, it's actually multiplied the work we had to do. Because we try to do a whole lot more with buildings than we used to do 10 years ago too.
They're more complex also.
Yeah.
What happened with BIM is it front-loaded the process, and then there's so much happening at the beginning of that, less and less towards the end, versus all these problems were being found or identified in the construction side, building walls got demolished, things moved around, lots of ways, still there is, but it shifted the workload from the end to the beginning.
So one of the biggest complaints you'll actually hear from people in the industry who have been doing a lot of drafting for years is that, oh, it just takes me so much longer to model the building than it did to draw it. Because let me draw it in AutoCAD, I'll get it done a whole lot quicker. But it's really kind of a false economy, because what would happen is, as you just draw it in all those two different 2D views, you're not seeing problems, you're not really resolving things in a true 3D sense and understanding how it's going to connect together as a built system. You figure, oh, that's going to happen later on sometime downstream. And what BIM does is it actually does it pulls it right up to the front. So as we're putting down every wall, you have to think about really, well, where is the location line? Is it going to be on the inside or the outside of the wall? I really have to start thinking about what the materials are of the wall and how those connections are going to happen between the floors and the walls. So in some ways it's more complex, but you're just really modeling.
You're moving around the work.
Yeah.
From the end to the beginning.
Yeah.
So which other teams just started to model? We have 2 teams. You guys some sort of started, but not really. Who thought about the workload and the sharing of work, even if you haven't modeled? Okay.
Right.
So then this is the class you will be thinking about.
We'll try to lay a foundation.
We'll be getting together and we like this one we have to do. So
we will hopefully lay a foundation to help you make some good decisions. That'll be a good goal for today.
But just remember, the goal is not modeling the building. I know you can model the building. There's more. It's a simple building, and you guys are like all engineers or studying engineers. The goal here is to model the building in a innovative fashion. Okay? Just remember, even if you fail at it, time process, not necessarily something that is easy or
Okay. Okay. Let's go ahead and we're going to open up some models of some buildings that are a little more developed and talk about just kind of linking things together and some of the different things that are in place to help make it easy to work back together. Okay. So this is kind of the notion that we're going to work with several files and bring them all together. And if you downloaded that zip file, please unzip it and see if you can open up the model linking folder. And let's go ahead and we'll open up the one that says architectural model new version and see how that works. What I'm going to do is rather than just double clicking on, I'm actually going to open up Revit first. It's actually probably still a 2013 version of the file.
14.
Yeah, so I need to do the upgrade.
I see. We have the 14 here.
You're fully up to date. You're more up to date than my classroom. So cross our fingers and hope things go well. What I'm going to do is just within Revit, we're going to do a file open. And I'll go popping on out there to my little thumb drive. I'm going to open that one that says architectural model new version. I'll just open that thing up. Okay. What will happen for this model is I think it's going to do a little updating along the way because it's going to bring it forward to the new model format. I'll say that's just fine. It can update it. Kind of something to watch out for. Make sure that as you download it, I think you've all previously downloaded software, probably all are working with 2014, new version of software. One thing to watch out for is files aren't backwards compatible. So if you work in 2014 in a file, and you go to a machine that has Revit 2013, it won't open the file. It's always forward, but not backwards. If you have an older file, that's not okay. Gonna say that, it needs to find something else there.
Just on outcast, we could take, we were able to say like the whole query.
Yep. Well, we can run it. The database format they keep on making changes to in such a way that you can't just do a say that. So I apologize for that. But that's sort of a reality.
This way, there's so much information in the model. So not as simple as lines anymore.
Yeah. The problem is really with every new release, they have new capabilities. And the database structure gets richer and richer. And the problem is it's how to subtract that stuff back off.
But if you don't like something, you can always blame Gwen.
Blame me.
He's representing the entire company here.
That's okay. Or I can even show you some tricks. There are actually ways to get things backwards compatible a little bit. In fact, I think virtually later in the class is going to have you experiment with transferring some other kind of BIM modeling systems. So there's some formats like IFC where you can actually save your Revit model out in that common format and bring it back into the older version. Okay. You lose some information. There's always some sort of loss along the way, but you're never completely down a well. There's always some way to kind of get it out there, and that's one thing we're here to help you with. So we're on a journey through this class together, and once we're starting this together, like as you get stuck in different like dead ends along the way, we're here to help you kind of like figure out your way, how to backtrack your way out to success. Okay.
Yeah, Glenn has been very good. Actually, he's been like up one night with one team, right?
Whatever it takes. It's really. No, we've never lost anyone. Yeah, everyone survives this class, so you're going to be okay in the long run. Okay, just so you get a simple sense of what this building is. This is a real simple little building I did a couple of years ago. This is a demonstration of how different systems of the building can kind of come together. So within this building, you'll see that it looks like pretty much a little architectural model of a 3-story building. You might imagine this is like kind of a retail space on the bottom with some office space above. It's a little sample building, all done just in Revit, primarily to demonstrate the architectural modeling tools. And you can look at it in terms of the 3D view, or we can go switching over, look at the floor plan views, different floor plan views, or the section view if you want to switch to one of the section views. I'm going to rearrange my screen just a little bit to kind of make it easier for me. I tend to like a slightly different layout, and it's really a matter of personal preference. There's project browser which shows all the views, and there's encompassing the properties palette. And I actually like to kind of keep those separate so I can see more of each of them. So if you want to do this, here's how you do it. You just kind of drag the properties palette. I usually put it over on the right-hand side, right on that side. And that way I'll see more values. Again, nothing special about that. If it's over there and you don't like it, put it back to wherever you want. You can just drag those little things, tile them however it makes the most sense to you. But you get used to things. So I'm going to put the properties palette over there right now. Okay. as you're looking at these things now, you'll see that there's a list of different views of this 3D model. There's some section views. If you want to go ahead and take a look at it that way, you can switch to one of those. Then we go to section 1. That's a big sideways section through the building. Section 2 is more a longitudinal section through the building. And you might notice this model is actually a little bit rich in terms of what's going on, in that there's the architectural elements, but when you really get on down to it, you'll see there are structural elements in here. There are structural columns, there are structural beams, things like that. But this is something that's known as a linked model. So let me kind of tell you what I mean by that. Okay. The architectural models or elements are easy to get to. I get to that door because that's part of the architectural model. I get the wall as part of the architectural model. But what happens is if I try to get to, for example, one of the column or the beams, okay, I can't get to it. What happens is when I try to select it, I actually get this like a blue box around the entire thing and the entire structure like that. And what's showing there is that it's really there's a linked model, and linked models have this nature I can look but I can't touch. Okay, I can walk to them, I can measure to them, I can do all these things, but I can't actually get in there and change the structural model. It actually is sitting over in a separate file, probably on someone else's machine halfway around the world that we're collaborating with. Okay, but I'm able to kind of see it here. So you can have whole models together and link them. Just to give you a sense of how that works, but we open the architectural model here. There's a link file, the structural model, which is kind of been inserted into it. Okay. Let's go ahead and show you the linked model and make a change over there to show you how this thing kind of fits together a little bit. But before I go through and do that, let's talk about really some things that you can do to help make your life easier before you start linking and subdividing the work. So, if you go to the floor plan view of any of the different levels, one thing you'll notice that using all of these different models really helps a lot with grid lines. So let me kind of say that before you do anything in terms of modeling your overall kind of structure, before you put a whole lot of walls and have architectural elements in your model, one of the first things I really advocate doing is put down the grid lines, whatever basically horizontal and vertical grid, and use it as a point of reference to really kind of hang the entire project off of. Whenever you can, measure things relative to those grid lines and use those as that point of reference. All the different model files, the architectural, the structural, the MEP, we should all have those same grid lines in there, and we use that as a way of coordinating and kind of keeping everything lined up. So before you do anything else, just lay down the basic grids.
And that's how most of the teams start. So they have the grids, they're like their landmarks, and then they share those files, and then architectural modeler starts doing architectural components, and structural modeler starts doing structural, and so that they have those reference lines to get those two pieces together, right? You don't want your buildings the lower left to correspond with the upper left. You want them to overlap, and those are their grid lines, basically.
Yeah.
Reference lines.
Your most important reference, get those right. The other thing that you really want to establish very quickly is if you go one of the elevation views, I'll just go, it doesn't really matter any of them, it'll show the same in any of them. You go south. Yeah, just figure out what your level scheme is going to be. Now, I use a scheme in most of my models, which is basically right at the top of slab, okay, or top of subfloor, depending on what kind of structure you're working with, because typically not the top of the finished floor. It's usually at the top of the slab, and then from the roof it's actually measured to the bottom of the roof. Seems to be the convention the way Revit does it.
Are we recording?
I think so.
Okay, just checking.
Let's make sure. Hello? Yeah.
They use like, when they start level 1 and 50 and then go up. There are some like,
Oh no.
you can also let them get the other roof or not.
Well, what's going to happen is if you lay the first one out at 100, then you put the next one at 115 or 120 or whatever it is, you can do it that way. Or if you just want to put it at 0, 15, 30, and then you can move them all up together, you can move the whole project reference point up too. Either sort of way, but yeah, the more you can sort of lay out properly up front. Yeah. I typically just leave it at 0 as a starting point, but yeah, it may be easier for you though, since you're working off a set of drawings that are already, kind of referenced to a specific elevation. You put it at 100. There's nothing special special about the space. It's really just X, Y, Z, wherever you want it to be. And we can move that origin point to 0, 0, 0 when we need to. But once you set it up, it's so quick. Yeah, get it set up where you want it in the first model before we start linking other models to it. The only way we get ourselves in trouble in this whole scheme is if after other people have linked to your model, you move your 0, 0, 0 around, you sort of just make a big mess for other people to catch up with you. Okay, so that's why I say, before you put a whole lot of time, the doors, walls, windows, and stuff like that, get the levels, get the grids in there. You just gotta think about your scheme. Now, I tend to work with a fairly simple scheme, just these top of slabs. You know, some people will put the ceiling level in there and the floor levels in there. You can put all sorts of intermediate reference points. You know, you have some hat height or some intermediate level with equal height. You have a level or reference levels to it, reference lines to it. Okay? But I think keep the level pretty simple. You know, but how tall is your building?
I don't know. I don't even know. I have to go check. It's not that tall.
Okay, so is it like 3 floors and then a roof and then a peak?
Yeah, it doesn't have the third floor. It's one of the cinematic art buildings,
So
and it
matching.
has studios, sound studios. Yeah, first and mezzanine.
Okay. Okay. Yeah, it's good to think about this. This is actually one of those good arguments to have at the beginning of the project. Is really, are you going to consider that mezzanine separate floor level? You just have to agree.
Yeah,
There's no right answer to this. You just have to sort of agree to whatever your approach is.
On the section of the design that we have, I think, at 1.5 level, it has. So, we really like that.
Either one, you have to.
Yeah.
So as long as a team you decide, I'm going to fit mezzanine as a new floor, or it's going to be 1.5 level. As long as you're in agreement, right? You don't want the architectural person to treat it as a floor, the other person as something else, and then it doesn't.
Here's a good way you might think about whether how to make that choice. It's really things that you want to be able to reference to, such that if they move, other things will move with them. Okay, should be their own independent levels. So floors tend to be their own levels in that you can place all the furniture, all the equipment, everything can be referenced off of level 1 or level 2. And later on, when I decide that there's really not enough floor space and make it 15 feet as opposed to 12 feet, I want to move level 2 and have everything that is based on level 2 with it. Okay, and I can reference things either at, I can put it above, I can put it below the level. Okay, but that's kind of the limit of control. So if at the mezzanine level, there's either furniture or equipment or things that actually sit at that level, such that if the mezzanine moves up or down, you don't want to say it's not level 1 plus H. It actually is its own distinct reference point. Yeah, there's things that will sort of push you towards saying, oh, that's sounding like a real level. And like just push you over the edge and say, yes, okay, I want to make that a real level so that if I move it, no care about it.
And I know why some of these questions are coming. We're giving you 2D drawings and asking you to model the building. But in fact, what we're asking you is things like designers. And so if I could have a perfect class, I would make a design and a model. Obviously, we don't have time for that. So you have to think as designers, engineers, putting together this building, not literally. My end goal is not getting one-to-one match to that 2D drawing to your 2D drawing.
Right.
And it's difficult because we have an end product. So you're actually trying to get from the end product to the beginning to the end, but that's not how buildings are designed.
The reverse engineering is actually one of the hardest things.
It's hard because you have a literal drawing in your hand you're trying to match.
It's definitely tricky. Okay, so we got this basic notion of these grids and levels and stuff like that that are sort of pulling this all together. Let's go ahead, I'm going to close up this architectural drawing. We're going to open up the structural drawing, the linked model, take a look at that. And mess around it a little bit, then come back to this one. Okay, so just to sort of give you a sense of what we're doing, let me go ahead and I'm going to go back to that big section view, and even in here, let's see, take a look at like these ceiling joists right in here. There are these, you know, that are kind of hanging around in there. You'll see they're kind of hanging above the ceiling right now. We're going to go off to the structural model, make a change those, and make it so large that you can actually see the difference when we actually bring it back into here. Looking for the sense of how this all works. So let's go ahead. Actually, so you see how things are actually linked together. Let me do this. Let me go to the Manage tab. And under Manage, we'll actually find Manage Links, and you'll actually see that the structural model is listed in there. It's loaded right now. It has a file name over there. And basically, it's set up so that if we reload the model, if we open the architecture model again, we'll bring in the newest model. But if two of you are working simultaneously, watch out for that. If someone's working on the structure over here, and you're working on the architecture over there, it won't automatically reload the structure until you either reopen the architectural model, it'll reload it at that point, or if you come over here and say reload, at that point it'll bring it reload to that. So just saving it just doing that. Yeah, it's going to do a reload, but it's not 100% dynamic. Okay, so this model is looking kind of okay. Let me say okay to that. What I'm going to do is just since I upgraded it, I'm going to save this as. And I will go ahead and save that as 2014, just so when I come back, I don't have to do that update again. We'll close up this architectural model, and we're going to go take a look at the structural model, which is linked in, and then we'll show you how to create a linked model. Okay, so we'll close this on up. Actually, let me kind of show you some random little tricks, if I can. There's lots of little buttons in here. There's so many little buttons in Revit that, yeah, it takes a while to kind of learn them all. Basically, there's a series of different windows open right now, and if I really want to close out this model, I can close out all the windows. It could be a lot of windows open because I've opened the section, I've opened the elevation, things like that. You can take a look at all the different windows. There's actually a little, where is it? The menu, mine's kind of a little compressed right now. It'll show me there's 4 different windows open here. Kind of a quick little shortcut. I just throw a little shortcut in along the way. Something that's actually useful if you're going to be closing something out, you know, if you have a lot of windows open, is right next to it, there's this little thing that says basically close all the windows which aren't currently open, aren't currently visible. And that just closes a bunch all at once for you. So you just have to close them independently. And then it'll be a one step to get rid of that. But again, just little random things along the way. Okay, put away the architectural model for just a minute. Let's go ahead and open the structural model. And if you go to, under the model linking folder, take a look at the structural model. It's going to upgrade this one also.
So while waiting for that, let me play the devil's advocate.
Please. Yes.
What if they change, after linking, the name of the file?
Mm-hmm.
What happens?
What is going to happen is it'll still be looking for the old name. That's actually, I was thinking ahead how to avoid that situation. So good that you went down there. Okay, if you change the name of the linked file after the fact, if I'm going to change the structural one to say structure 2014 in a second, when we go back into the architectural thing, hey, I can't find the old files I'm linked to. At which point, you just need to, in that manage links, you point it to the new release file. Okay, so it's all just sort of a file naming thing.
I asked the question because housekeeping and being like really organized is extremely important. That you don't want to lose what you linked to and what is the latest version, and then you bring in something that was 2 weeks old, and it's like, no, this is not what I want.
Yeah. So relative to that, this is kind of a good point that has to do with backups and stuff like that, because as you're working along, okay, it makes sense to have, say, older versions of your stuff. You can always back up to older versions. So, yeah. What? Oh, every time you hit the save button, it does create a backup. But what I tend to do is at the beginning of every day, I'll just make a copy of where I started the day from, and then kind of work through the day. Keep on changing the day. But when you're linking files, I would use a slightly different scheme than what I usually use. What I'll typically do is I'll go through and it's house A, and I'll save the new version house B, house C. The problem with doing it that way, the way I typically do it is if you have a linked file, every time you change that name, it's going through and it's breaking the link. At that point, they keep on giving it a new name. The better way to do it, if you're going to be having a linked file scenario, is just at the beginning of every day, just do a copy and paste in the file system, and save it as house September 9th. Then at the beginning of the day, save one house September 10th, so that you're always leaving the current one is always having the same name. That just makes your life a little bit easier. But then you don't have to kind of keep on relating it every time.
And
So,
you never trust software. You trust yourself. Trust
Exactly.
me, because many people in this class, my experience, in my group, we have seen the blue screen or something, the file gets corrupted, something happens. So you have to make sure that you have redundancy. I'm sure that happened to you. See?
it always happens.
And sometimes it's a lifesaver, right? You go to autosave file and then find it, but sometimes, it's never.
With that, so I'm going to use it to be a lot. Working through it with the videos
Very good. Okay, so now we're looking at the structural model. Most of you have the structural model open? Excellent. Okay, let's take a look at that for just a second. You'll see that this actually has a linked file in it too. I can tell because there's like this big blue box, which seems to make some things, well, actually it's a section box. I'm lying to you. This is just something that'll let us kind of very quickly, kind of in 3D, cut different sections. So you can sort of just take a look at the structure. Let me just orbit that around a little bit. You can see this is actually a fairly well developed structural model in terms of what's going on. We got all the columns, the beam systems in here. It's not looking too awfully bad. Okay, you can sort of see all the little beams in there and all that kind of stuff hanging out. Okay, we're going to be talking about how to create this thing next week in terms of getting all the detailed structural elements together. It works very much like the architecture elements. Just a couple of tricks for working with structural things. And for each of these different elements, you can see, this is like a wide flange, it's 14 by 30, something like that. There's this other wide flange over here, it's 24 by 84. Just so to kind of relate it back to what you learned last week, like all these are just families. There's just different steel member families that are loaded in like from the library. And then they're kind of customized to be the precise length they need to be to kind of match just exactly what your geometry is. But if you want to go through and change those, it's really as simple as actually just changing the families around. So for example, if I want to go through and change this one, right now it's pinned, it's part of a system. I'll unpin that so I can change that. You'll see I can go through and change it and make it, it's another type of wide flange section. I'm going to make it one so obscenely large you couldn't miss it if you tried. Okay, I'll unpin that one. I'll make that another one. A 44 by 290, so it's 44 inches tall, 290 pounds per lineal foot. It's very, very large.
Okay. Show
And I'm doing that.
change family. Last week. Okay.
So anything you want to change as a family, it's pretty much just selecting it. These are pinned because they're part of a system. But I'll make that a bigger, so I'll make that slightly a little smaller. Okay. So we have some different sort of families that we're going through and changing here. I've made some changes to my structural model. The cool thing is the structural model is active computationally. We can take a structural model, run it through a whole structural analysis program, and actually figure out what the size of these members should be, replace them with the proper size members. It's really quite cool that it's not only just here to document what your design intent is, but it's really an active computational model. And we can go through and do all that. Once we've made some changes, our structural engineer has decided there's some very heavy loads happening there in the center of the building, and we need to go ahead and change the structural size of these things. We will save this away, and we're going to send it on back to the architect, because the architect's going to have to figure out how to take care of this. Yes? Oh, which one can you not unpin? Because I'm not saying you should be able to unpin. Let's see. I do not know offhand. We'd have to look at it. Just try a different one for right now. The other one's working? I'm not sure what the story is with that one. I have to go back and look at. Actually, just try changing it. I think it's. Try changing that. Okay. Let me tell you what's going on, because I actually do know now that I sort of saw what your question was. Here's the deal. Just a little bit of a preview ahead to where we're going. The beams which are actually lined up with the columns are actually individual beams. Those are like girders that are sort of collecting loads from other things. The little intermediate ones are part of a system, and they're pinned because typically you put all the intermediate ones the same size, so if I want to change the entire system I can, or not. Okay. But it wasn't pinned ultimately because it wasn't locked. So in that same sense, you can just go through and do this. Just to give you a sense of how this gets to be fun. Maybe right there. Let's see if I can go up here. I'll go up to the level 3 framing. Even up here, show you. This is a whole system of different things. There's these W14 by 30s. I can select those. And just to even show you in here, I want to change them as a group. Oh, what do I have there? I don't have anything I want to show you. Though. Let me load in a different type of structural element just so you can sort of see. I'll say insert, load a family. And again, we're going to do this next time, so don't worry if this is going by a little quick right here. I'll just bring in a K-joist as opposed to these big heavy ones.
Did Pedram show you how to bring in?
So I'll just load in kind of a 2-foot deep K-joist. But the nice thing about these systems, and this is where you really start to see the advantage of the BIM modeling techniques when you're kind of putting together the structure you're building is, if, for example, I want to go through and change to that K-joist, I just sort of make the change once. Okay, it'll apply to that whole system. And then to that whole system, all those different members have changed simultaneously. And the cool thing about that is, since it is a BIM model, not only is it changing here in the floor plan, the elevations are proper now, the 3D views are proper, the section views are proper. That should all be looking fine because there really is only one model. There's no such thing as a drawing anymore. And there you go, those little K-joists. Kind of floating around down in there, looking a little bit different. Okay, so we as structural engineers have been making all these fantastic changes that we know need to be made. We're going to send it on back to the architect because the architect's going to have to sort of incorporate these things and see how it all resolves back into their model. So I am going to save my work away. I just actually did a save. That's saving it under the same name. What I meant to do is actually do a save as, so that the devil over here gets to see me suffer on the other side. Okay, project structural model 2014.
I like that kind of stuff. It's better to suffer now than suffering.
You should
I'll
watch
make
me
you
suffer as opposed to you suffering. Are there questions? Questions? Okay. If you got that saved away, let's go back and pull it back into the architectural model and see how that works. So I'm going to close this one up. I'm going to go back over to the architectural model. Now in this case, the architectural model is not going to complain right offhand because it actually still found the thing that had the old name. I didn't actually delete that and wipe it out. Okay. But if I really want to link it to the new structural model as opposed to the old structural model, okay, what I should do is do a reload, kind of pull that in there together. So if you ever find it complaining about the naming because you changed the name, or if you ever need to do a relink, it's under Manage. There's Manage Links. You see it's still pointing to that old one. If I say Reload From, then I can point it to the new one. And just bring it in there. That's okay. Now, this is kind of a funny thing about linking. I'm just going to warn you about this, and you may not be too worried about it. Here's what's actually going on here. The architectural model links in the structural model. But the structural model doesn't want to be all by itself. It actually linked in the architectural model, which linked in the structural model, which linked in the architectural model.
Infinite
and it
loop.
becomes this, oh no, exactly. So it says, hey, we don't like infinite loops. This is bad. There's too much recursion here. So what it's saying is, I'll bring in the structural model, but you know that architectural model, which is actually me, and I'm not bringing that in. So that's what it's trying to tell you here, is that basically the nested links will not appear, because then you actually have two copies of it, one on top of the other. So it tries to be a little smart about that. That's what it's doing. Okay, we'll say okay. Theoretically now, with this new improved linked model, let's go ahead and see if we can figure out and find those vertically sized beams. And
That might not be the right section.
Exactly. What I have to do is find where they are. I think they're over. If I just rotate it around, or what do you think?
Yeah, rotate a little bit.
I'll find them yet. I know they're here. We cut the section back a little bit further. It's just a matter of which I should actually pay attention to what I'm doing, right? Well,
You use it like there, we don't know how to come there.
oh, down the end?
Yeah.
Okay. As long as you know where they are. What I'm doing now is fumbling because I'm trying to do it at a very oblique angle. You come back over here. Oh, there they are. Look at those. Those are big and ugly. Okay, so now you see these supersized beams that are kind of hanging around down in there. You'll see I have some big ones kind of hanging around in here. I've just been messing around with this model. But the important thing about this is that really by linking things together, you can have several different people all working on different pieces and they're all staying in coordination with each other. Now, linking actually does work two ways. And I'll show you how to actually set up links, because you'll want to do this in your model too. Probably sort of experiment with that and actually do these experiments, or just kind of have experience of doing it. But yeah, you can link the structure into the architecture to the structure. You can go both ways, because really, ultimately, everyone wants to be able to see the other pieces that they're not seeing. Okay, so let's do this as a way of getting going with this. Let's actually create a new little building, one that we're just doing ourselves with the simplest of stuff in it, just so you sort of get a sense of how that works together. So I think that would actually be a really good starting point for you. So how about this? Why don't you go ahead and just open up a new project file. I'm going to let it be, the construction template actually includes a little of everything. I'm going to let it be the architectural template for now. The template's really, the only difference there is what elements are loaded in as default by family. So there's not really a huge penalty for choosing one or the other. Construction sort of includes everything. So here we are, we're looking at our new blank space. I'm going to make some little building, 20 by 40, something like that, maybe 2 stories tall. Very simple. But before I go throwing all my new walls down, I'm going to start by putting down some grids. That's going to help me out. So let's go ahead and do that. We will, under the Architecture tab, find in the Data section the Grid tool. In the Grid tool, I just go through and pull from left to right or so. Some basic lines out. And we covered this last week, right? Put some of these down? Beautiful. So just go ahead and I'll make it like 20 by 30, something like that. There's nothing precise about what I'm doing right now. This is really just to kind of show the point about linking. I'll put a couple different grids going in this direction. Okay, so I have a nice little 2-bay system for my building right now. I wasn't really all that clean on my grids. Let me kind of show you some variations on that just so that you have some nuance. One thing I can do is over here, there's 1 and 2. The third one was drawn was 3, but if I want to switch to an alphabetic scheme as opposed to numeric, I can put A in there. And then I'll start putting the other grids in. Now I can draw the other grids. I love drawing grids. That's actually pretty nice and easy. I'll make that maybe 30 feet across. You can always move those later. Notice the next one that comes in is B because it picked up the alphabetic scheme. Another thing that's kind of cool to do though is if you're going to put a lot of grids in there is to offset the grids. Because very often, I'm not sure how your building works, they're on these very regular grids, 20 feet, 20 feet, 20 feet, 20 feet, or whatever it is. So the way that works is under the grid tool, there's this off choice right here where we can select a line and just put in an offset. So if I know that's going to be, say, 25 feet, I can just offset, and you really quickly generate a whole grid system that way. So just throw some grids down. Doesn't really matter too much what we're doing right now. In the other direction, we want to make sure we get those floor levels set up right also for this building. So let's go through and I'll switch to any of the elevation views. It doesn't matter. We got level 1 and level 2 over here. They're 10 feet apart. Okay, if you wanted to go through and change it, for example, to be that 100 feet or something like that, we can do that. Let me just go ahead and I can do that a number of different ways. One way is to actually just take these things and actually just move them up to 100. What else could I do? I could just go ahead and put in the value there, 110 and 100 there. If you do something like that, watch out though, because generally what happens is in your grid system, they're still hanging down looking pretty low, so you might have to pull them up. Now, I don't know about any buildings you've seen lately, but 10-foot floor levels is really pretty uncommon in anything commercial. So you're probably thinking about 12, 14, 15 feet, something like that. So maybe make those a little bit bigger.
For midgets.
Because that's, you know, we could walk through that building.
Size.
But, yeah, there's no room, no ductwork. It's a hobbit house. Okay, then for the levels, we can do the same thing. We draw another level. Let's give yourself a third level. And if I go to the Architecture tab, say Levels. Oh, if I choose that Select tool, I can put in the offset. And again, that's just kind of a nice way of getting another level. Just, you know, the nice thing about offsetting, you'll learn to love offsetting. If you do a lot of drafting, you probably are very familiar with offsetting. But it's a great way to not only draw, but it just places it in at the same time. So in the long run, it saves you a lot of time. Okay, so once you have these things set up, you're looking good. Go back to the floor plan and just go ahead and put yourself some basic walls in there. Oops, I should tell you about this. Notice it seems like some of the grids have disappeared. What's going on, old devil over there, is that basically the grids have this notion of how high they run and how low they run. So since I stupidly moved my building up to the 100-foot level, they're looking pretty good in this direction, but I need, if I shift over to the east-west direction, I need to extend them there also so that they're going up. And I can't do that very well. Oh yeah. So if you run into this instance where your grids start disappearing on you in some of your different views, take a look at from the elevations whether they actually have a span also. So if the grid doesn't span those floor levels, then it won't show up on that floor level. See what's going on there?
These grids will save your life, trust me. So make sure that you, it seems silly, but they're very important for all of your team members to be on the same page.
Okay, everyone got grids? Yes? For almost all of them, if you see that little green line, that little inference line, if you pull one, they'll tend to pull together. Oh no, move would actually work also. Yes. Yes. Either way, in that case, it probably would have been. I allow that. That's good. That probably would have been better as a move. Yeah, I don't know. I'm always extending things. But like so many things, it's, yeah, 6 of one, half dozen of the other. But no, good suggestion. Move it actually would work just fine for doing that. And that way they would have kept the same length, so I wouldn't have had to do that. An added bonus. Touché. Okay, so we got these. If you have this, go ahead and just put some very basic walls down.
We have another question.
Another question. We got.
You have a question?
Oh, sure. Would you like to offset the grids or offset a level? What would you prefer? The grid. Okay, no worries. Let us, for example, I am looking at the grids right now. I'm going to add another grid above, another 15 feet above or something like that. So what I will do is I'll go to, in the Architecture tab, there's a grid tool, okay? And these are for drawing. All these ones that just sort of look like we're going to draw a line. The one that looks like a little green guy, and with the arrow, that's for selecting. And what I do is when I choose that, I have the choice of putting in a distance. So I can put in there, oh, I want to put another grid in maybe 15 feet, not 51 feet. Then I will click on here. And notice when you offset, just a little nuance, if you are hovering ever so slightly above or ever so slightly below, it'll sort of suggest to you where that line's going to come. And I'll put it just above. Okay, so offsetting will learn, it'll become your best friend. Okay, go ahead and put some walls down. Let's go ahead and put some walls on level 1 right now. And using your techniques that you learned last week, you can choose any wall type you want, throw a couple windows in, just enough to give us a little bit of architectural definition. I'm gonna choose the wall tool. Let's see what I got in my list of walls here. All sorts of interior walls. Oh, I'll go for this EIFS wall system on metal studs, a very common system we use in this area. Okay. As I'm placing my wall, a very important thing for you to pay attention to is this notion of where is the wall location line. Because this is one of those ones that comes up a decade again. It gets you later on if you don't get it right. So as you're placing these walls, and for example, if I'm putting walls on this grid line, think about, is the center of the wall on that grid line, is that the outside face of the structure, is that the outside face of the finish? Think about where that is. Because if you make the right choice, it'll be very easy later on. If you change anything, the location line won't move. The thicknesses may move relative to the location line, but the location line will stay the same. So you want to sort of put them in the right place. And just by convention, there's all these funny choices out there. There's core center line, the finish faces, the core faces, the exterior. Of all those different choices, the one that I almost guarantee you 80% of the time, which is not such a great guarantee, is going to be the right one, is for one of the faces of the core. Because what happens is, as the buildings are built, the things are measured to the structural faces, structural core, and the finishes are just put on the outside surface of that structural core. So if this is like metal studs with foam on the outside of that, it's really, the metal studs are the ones that are really at the precise location. The metal, or the foam insulation is really beyond that. Or that. But it's almost always the rule. So you have all these different choices, but it really comes down to really where is it that the material should be.
And these are some of the things that the team you decide. If you have two architectural modelers, right, you want to get together and decide some of the procedures you're going to follow. One of the best ways is to write it and share it in Google Docs. That's all you have a documentation. And if you get confused,
Definitely.
like I can't remember were we using the core or the center or the finish line, you just go to that reference document so that if you're like, I think that team is using two architectural modelers, maybe let's say left side and the right side. When you bring them together, the walls align.
And walls are Joel. Yes. The wall center line includes everything from the interior finish to the exterior finish. The core is just the floor layer, like the block layer or the steel layer or the wood stud layer. So, yeah, it's a structural piece. And in every wall type, you actually define what is the core and what isn't the core. This is
because your walls might not be symmetrical, right?
Yeah.
Inside and outside.
Inside there, don't worry about this level of detail just yet. It ultimately, some layers are considered core layers, some layers are considered finish layers. But it's just that sort of, that thickness of whether you want it to be, just the interior core or the full width of the material. But
like here, the walls have different finishes on each side.
Yeah. But the cool thing is, they almost always measure to the core.
We create a template with all that information that we need, like a starting template. Like say, I want to grab the outside, this from the outside and this from the inside. Like the measurement from the official line, and create a template and really for everybody.
See, it's interesting about which things are carried by the document and which things are carried by the application. So you're right on target about saying whenever you can create a template that you can share. What will happen is, even as I do projects now, I never start from scratch. I always start with some old project where I have most of my favorite families, I have my standards and my line weights all in there, and you use that. And in most offices, there will be a template to use that really, they've taken a lot of the decision making and given you the standards so you don't have to recreate that from scratch. So those things, yes, will come as part of the template. There's a funny issue about the measurements. By default, will it be the center or the edge? That's actually, for whatever reason, it's part of the application because it's sort of considered your preference versus in the template. But whenever possible, the key to this is, in fact, it'd be a good thing even amongst yourselves, if one person who's taken the lead on the modeling can then share a template that other people can pick up, you won't all be recreating these things. You'll start from a common basis.
And for the things that you can put in the template, then you create that document to share, so that you have a reference line. Agreement.
Cool. Okay, let's put in some very basic walls in here. I'm going to put some walls in here. Oh, I'm going to put them not to the wall center line. I'll do the core face exterior. And I'm just going to draw some walls kind of coming on up. Again, don't worry about precisely what you're doing. That's enough to get me going. Just to zoom on in and give you a sense. Oh, now here's something that's kind of interesting. I've done all that careful work of thinking about really just exactly where this wall is going to be located. This is the center line, but it looks like it's kind of hanging around the center. You might sort of wonder, why do I not see that all these fabulous layers of the wall and like all this incredible detail that's available in the model? And the answer is really just, it has to do with something which is right here in a little bar of widgets. It's the level of detail that's being shown. So right now this is being shown at what's called a coarse level of detail. I'm going to turn that up to medium refine. And if I do, you'll see that I can actually see the layers of the wall. We'll put it back to coarse again versus fine, or medium. Now, why do we have this? When you're doing the detailed design, you want to show the fine, and some views you really want to see all that, but it takes a little bit of time to render all that stuff. So where you care about seeing detail, turn it up. Where you don't care, if I'm looking at this from 300 feet away at a very high level scale, I don't care about the detail of what's happening in that wall. I actually confuse things. I don't want to take the time to render it, so leave it coarse. So be aware that every view has this notion of how coarse and how fine, and you should sort of put that just really based on how much detail you really need.
But it's there. It's
Yeah.
just a toggle in and out.
Yeah,
Really.
it's just there as an efficiency thing. Okay, so this is enough for my basic building to go ahead and get started. Okay, I've done my little building here. Actually, one thing I wasn't very careful about at all, and I got to fix it now after the fact, was let me choose all those walls. Actually, let me show you what I'm doing right there. If I choose on a single wall, you'll see that it's unconnected right now. That probably wasn't a great choice. What I probably should have done was be a little more careful as I was looking and say, I want to go from level 1 to level 2, be precise about that. It's always better to hang off those reference lines, like the levels and the grid, as opposed to it being free flying. I'm going to change that so instead it goes from level 1 to level 2, not just 20 feet. And the reason I want to do that, 20 feet is really sort of an arbitrary, it's a precise measurement, but it's not really related to like a specific project distance. Where level 2 is a precise project distance, it may also be 20 feet. But the difference is, if I say level 2, and then later on level 2 shifts 2 feet, the wall will shift and everything will move left. So whenever you can...
I think your height is 15 feet anyway, so I think walls are, second floor walls are up down.
But we don't like that. We're going to change that to level 2. I could bring it up to level 3. This is sort of an issue of how the walls are going to be constructed. And if I want to change a bunch of walls, I can choose a bunch.
So this is extremely important because it's setting a parametric relationship between objects or between reference points, right? And
Yes.
he said if you want to move the floor, the ceiling height, in the next iteration, you don't want to move the ceiling and then move each wall one by one. You want to link them, create a link between, parametric link between those so that you move the ceiling and then the walls move. Make sense?
So let's go ahead and show you that in action. There you go. Close that up. Trying to toggle this so we can see it all. So basically, what's happening is over here I have these walls. They're kind of looking rather stubby right now. That's because the actual height of them, as dictated by the levels, is a little bit stubby. The nice thing is, and I'll use your move technique, because I actually like that idea. If I take these two and I move them up like another 10 feet, you'll see as I'm changing things in the references, if I'm changing things in the levels, it's actually going to go through and change them over in the left-hand window also. And that's a good, the best part about kind of tying it all together parametrically is you can sort of like get those things together. Okay, so we have been hanging around, going through and making some basic little architectural models. Why don't you go ahead and save that one away? Save it just as, and you can call it whatever it is with your team name, save it somewhere you can do it, and call it the architectural model. And then we're going to go ahead and open up a new model, a structural model, and link the two together so you can start seeing how the two work with each other. Okay, and relative to time, do we take a break?
Yeah, let's take a 10 minutes break.
Great. So
Okay.
take 10 minutes. We'll hang around for anyone who wants to get caught up with that. So when we come back, we'll go ahead and make a structural model and link the two things together so you can...
3:33, we'll be back. And